English it will be. I will take. It will take me roughly 5 minutes to get into the flow of English again. So and then I'll die off probably. I don't know. Speaking of dying off, this talk is about the evolution or revolution even of SIM cards and SIM card development. This little chip or the picture that you see is when you scratch off the surface of your SIM card from your phone. If you do it today or now in such a way, there is a likelihood that it will still function. But if you are very uncareful, or, well, actually, it will break off pretty fast, and then suddenly it will not even work anymore. This is the technique that people do, researchers. I have a very high degree of gratitude with respect to Karsten Knoll and what they did many years ago on scratching the surface of a SIM card and how to get to key material or see how the paths are actually working on the circuits. So, see some people coming in? Yeah? Okay, come in, whatever. Very dynamic. So I work at KPN. Just to emphasize, this is not a talk about my work. This is just a talk about what's happening in this ecosystem. Just to emphasize very clearly, also on the recorder, hi internet, or boss, this is not about the work. This is just what's happening. It's just sharing knowledge. So, let's get back to history. So, does everybody know how the SIM cards actually worked and looked like many, many years ago? They actually looked like the big, huge cards, and I've seen for quite some years BlackBerries use those cards for many years after they kind of got miniaturized to the big mini SIM cards that we were used to, which then got moved into micro and then nano SIM cards, and that's basically what we are used to today. But there's another evolution going on, which is the eSIM. And that's what I'm going to talk about and how that is changing the way we work with key material in a SIM card in a mobile network. So, how did this work? Or how does it get started? It started with these guys. Apple, Samsung, and other devices want to miniaturize their devices or add new radios or add new other gadgets to their phones, so miniaturizing is a thing. And having a SIM card and then downscaling it to a nano SIM card just leaves at least that scaffolding around the SIM card to actually have still a slot, maybe even 2 SIM slots, to actually get into your phone. If you pull out the bracket, at least on my Nokia device or my Samsung device, it goes pretty deep into the card itself, and you need surrounding infrastructure to actually hook up a SIM card. And that's the nano cards. That's quite a lot. If you look at electronics, everything needs to be thinner. You want to have the battery thicker. There's going to be a physical problem in building these kinds of things. So this is why they want to miniaturize, and this is why they want to have no SIM card at all. But you need a SIM card to actually get your data on the mobile network. How does that work? This is why they've created a new solution, a eSIM chip. And you now also have phones, and there were phones that were equipped with a nano SIM card slot, but these are very unpopular. Those are thicker, heavier, and if you want to have a very thin device, then suddenly it's roughly 50% of the inside of a phone, or I mean a watch or another small device that is just the nano SIM card slot. So this is why they want to miniaturize it back into a chip. On the right side, you see a screenshot of the devices that you can buy today with support for eSIM. So these are the Pixel 2, the iPhone XS, XR, the Pixel 3, and there are some other devices now coming up. This is not counting the smartwatches, because then you have a few more. Samsung already sells a few of them, and it's very interesting. So there's a marketing driver to actually have a benefit for these kinds of chips. Also, it helps in the ecosystem of IoT. For people who don't know, the 5G specifications are still in the making, but one of the sub-specifications is specifically on low-energy devices, high throughput or even low throughput, and to build them into your refrigerators or your microwaves, whatever, all kinds of appliances. This is where they want to end it up. And if you want to have a physical SIM card or physical module in it, then you'll get into all kinds of practical problems, and I'll dive into that a bit deeper. You have chips inside of these devices. They need to be provisioned, and this new ecosystem does have some privacy problems, or at least some challenges. It's not really a problem yet, but I'll dive into that too. And yeah, this is just something that is now being emerged as one of those things on how to solve security problems in IoT. Why security problems in IoT? One of the biggest problems that you see in the IoT world is how do you start with a secure connection? How do you know that you have a connection of that particular device, and how do you connect that into your infrastructure? In LoRa chips, for example, there's already a secret key embedded from the plant. When they create the chips, there's already a secret key which is unique per chip. This is what you can order. So this is good because this bootstraps the encryption required for security, confidentiality, and everything that is around the privacy side. And this is what you can also do now with subscription. So this is that problem, you can solve that problem, and you have a subscription-based thing which makes it attractive for telcos and attractive for companies to integrate this into your IoT ecosystem. So yeah, okay, everybody is connecting everything throughout in this case, here's a nice picture of just how much stuff we're trying to connect these days. I mean, I think it's very interesting that we're putting up Wi-Fi these days into traffic lights. Did you know? There's a project that actually is going on and created right now, where your car is making a statement to the traffic light, hey, you need to get a green light because there's a car waiting over here. And that they create a green wave. There are all kinds of connections these days. Oh well, there is so much connectivity going on. This is why telcos, at least, are quite a target. If you can influence how the traffic is going, if you can influence how things are moving around, if you can influence data, that's attractive for both a criminal economic thing like cybercrime, but also for intelligence agencies, like who is talking to who, what kind of connectivity is going on. And this is very attractive to influence. If you have insight, that's good. If you can influence it, that's even better. That means that somebody else has an influence on your infrastructure. This is why we have cryptography. This is why we have privacy concerns. And this is why we have all kinds of laws to at least protect us. There are many ways of connecting IoT devices, phones, whatever. You've got LoRa, there's cables, Zigbee, Bluetooth, LTE-M. For those who don't know, LTE-M is a specific sub-specification of 4G, of the 4G network for industry mostly, where you can create your own group of devices who can talk to each other, but nobody else can join your secure group. It's one of those things. Also, the 5G will support such a thing. And what we keep forgetting is that the evolution already started many, many decades ago, where plants like these evolved from moving an actual physical valve with a human to an electronic system. The electronic system now became electric. You can now push a button and suddenly your water flow changes. That button suddenly is a proprietary network. So you will now evolve into Ethernet. And the other evolution that we now see is, why should we put in cables at all? Why can't we use Wi-Fi, for instance, in these plants? Or 4G or 5G, because you have remote plants. This is what you can see in the evolution in industry. Less cables, less money, less copper, less costs, more flexibility. Another cool application that we see now is, for instance, the checks, or at least the this is way of working with a drone, a multispectral drone that is running through a field, or at least in this case it's not running, it's flying over a field, making a scan. It takes roughly 40 minutes, if I'm not mistaken, might be wrong in the number, but it's roughly 40 minutes that you take the actual the spectral scan, you send it up to the cloud infrastructure, and then gets back to the farmer in his device on his tractor to actually know how much chemicals you should spray on this part of the field and not in the other part of the field. This saves chemicals, so that's good. It saves you in all kinds of chemicals that have to be put on the field, because otherwise you'll put in too much or too little. This is the cool thing that we can do now. But this is now being motivated and moved from a 4G network on the drone that is now being put onto a 5G network. And this is how you can see that in all kinds of unexpected situations, you have mobile connectivity or a SIM card. And perhaps within this community, you might know about the OV chip card PAL, the bleep thing that you can see. Well, some people got creative and did security research on this and created, saw some pictures. And one of the things that I emphasized on is that to see SIM cards on the inside of those devices. Why? SIM cards hold key material. This is how they secure the entire infrastructure over quite an open fiber optic network around the country. This was only information by open source intelligence analysis, of course. Another activity is that you see cars communicating, and for those who know, every car has at least one SIM card. Some of them don't, but they call with eCall, for instance. If you have an emergency, it's now a part of the European laws that if you have a crash, it sends out over the mobile network where you are, that you had a crash, that your airbag deployed, and sent emergency services, or at least opens up a call to a call center from your car manufacturer. Which is quite interesting. It adds safety to you, but at least all these devices are somewhat connected. They are only connected when it is when there's a time of impact, so it's not a tracking device in that sense, although it might vary per car manufacturer. Each car manufacturer is free to implement this in some sort of ways in their own way. But this is how you can see again why and how Wi-Fi comes in, key material, SIM cards and everything goes back into the ecosystem. Okay, this is on how we use it. And now something specialized, a special interlude slide is the glossary for telcos. Not everybody might have seen the CCC talks about mobile networks, but here, for the IT-centric people, if you talk about the certificate authority, they call it in the telco environment a CI, while we would say a CA. RSP is the acronym for remote SIM provisioning, so this is the activity of getting key material to your SIM cards. The MVNO, so mobile network, like KPN, T-Mobile, Ziggo, Vodafone, those are MNOs, and virtuals are Robin, Telecom, Lebara. They use the other guys' network infrastructure. And then there are other specials. When I say or have in the slides UICC, it means SIM card. And when I say EUICC, it's embedded. Then you have a chip. And when we're talking about an IUICC, it's integrated. Now it's part of the system on chip. Yeah, which is the system on chip. And then we've got two other specials that are only specific for eSIM, which is the SMDP Plus, a node where you have interaction with, and you'll see in the schedules later how that works out. So, looking at the changes, we are now going to provision key material where we had a device, currently a SIM card. These devices were created, provisioned in a secure environment. The key material is put into the sealed chip, then moved out. And then they end up in the shops. This is a bit different now with remote SIM provisioning. And there are many risks here, or at least new risks. And it's very interesting to see that at least that that one of the important things is how to safeguard confidentiality and availability in this network. So you've got at least risks who are quite some different between the customers or consumers, enterprises. There are different profiles for enterprises, and you can do different kind of cool stuff. And you've got governments who also have different motivations of how to look at the SIM card provisioning. Now let's have a look. This is a very simple schema. You have a phone or an IoT device, whatever, and it goes to the radio system. Then you have a base station unit, and then you have to register to the mobile core network. This is your device is coming alive, or you're trying to do something with the device. Now, what could you do with these kinds of things? What could you do with a cool SIM card? First of all, you have to know that the SIM card is actually running a Java card application. Not just one application, it's an operating system. So your SIM card is running a miniaturized operating system on the card, and you can have different kind of apps. One of those apps that we were used to, or at least saw in the past, were the apps installed on your phone, which are specific for a mobile network. So some of the mobile networks actually were transporting apps and all kinds of other stuff that you could not deinstall from the SIM card. You swapped the SIM card, you pushed it. The address book on your SIM card is one of those Java applications. It's a separate application. So technically, a telco could be able to say, okay, I'm updating this phone book application, or wipe it, or whatever. They have the opportunity to do such a thing. But there are also other applications, like the secure key management, at least for the mobile network. This one you use without actually knowing that it might exist. And this is where you have all kinds of key materials and special information stored in this card securely. And this is what we use to authenticate to the network. And the cool thing is, a SIM card is designed in such a way that if you scratch the surface, at least it's designed to be such a way, that if you scratch the surface, it should be that you might see the circuits, but the key material should disappear faster than you should be able to analyze it or scratch it off. That's the intent. Obviously, the quality of this is different from a hardware security module that might be worth 50,000 euros in a 19-inch rack into a data center, so there's a quality difference. But it should be similarly infeasible to easily extract the key material from these cards. And there's also the third-party applications. You might have heard something about that if you are from the Rabobank, that there was an app that you could do the mobile payment and pay with your phone. And the key material of the phone app of the Rabobank was not stored in the app itself, but in the hardware security module in a separate environment on the SIM card for extra security for the key material, because the SIM card is a hardware security module in a small essence. And therefore, it was more secure than on the app itself, because if you have a break-in on the application or your phone, you might have everything wiped, but you can at least, or stolen, and all the key material could be stolen if it would be in the app. But now it's on the SIM card, and this should be more or less too infeasible for an attacker on your phone to actually gain access to your keys and impose you for mobile payments. Another application was to do a virtual MyFair or Desfire card. So complete cards. This was done with one of the projects that was done by, if I'm not mistaken, Vodafone and KPN. Was to have a virtualized version of the NS OV card. So the complete card was in the SIM card itself, and if you bleeped your phone next to the station, that you could just check in and check out like it was a normal card. Downside is, of course, if your battery died, then it doesn't work so good anymore. And you could do all kinds of other cool stuff. So here's another schema of more detailed on how this actually works. So on the left side, you have the SIM card picture with your ISD, the TSD, the other TSDs. The green TSD is specific for the telco, and this is where the key materials are in a secure domain. SD stands for secure domain. And the other secure domains could be created on the file system of the SIM card as you see fit. And this is where it comes in that the telco is creating a file system. You create the file system. You create or state, I want to have SIM cards with this amount of memory in each of them. And you can now create a profile, and the profile could be used for various applications. One of them, or the mostly used mandatory one, at least for telco usage, is of course the first one. Those are standardized, and the other ones could be created by customers or are an open platform. For one of them, it could be used like in the banking system, which is different on a profile side than the MyFair and Desfire chip emulations. But okay, you see a picture on the left side. Hopefully that you can see it. It's a black phone. It should be on the left side of the red square, which is on the radio system. On the radio system, and the radio part up to this pole. This is the radio antenna that are scattered around the country. Here there's a statement. Okay, this part is encrypted and authenticated, and then you have a cable running from a rooftop up to the core, which is the BSC RNC MMA. These are systems that are used for when you want to have roaming, or at least a roaming between all the radio systems. So if you move from one place to another, you go to another radio. This is what those systems are doing, and they keep track of you in the backend systems, in the OTA. So this is the over-the-air update facility. The HLR, HSS, they actually do the same thing, or actually, conceptually it's a different system, but in reality it's typically one system. This is for 3G and for 4G. So this is also nice. Between the 2G, 3G, and 4G, and now also 5G, they change for the same kind of activities. They change the acronyms all around. If you work in telco, it's interesting. Per generation, you have different acronyms for the same stuff. So you have to learn a lot of things. But the cool part is, at least you're encrypted up to the network here, which is the first entry point after the transport from wherever you are. In the field, through the radio, and then to the core networks, and then it's on the internal side. All this is done based on the fact that there is key material in the SIM card to authenticate. And for those who, at least I got the challenge, okay, it's not complicated enough, but this is how it works. How do you get all these keys? Well, it's a symmetric encryption algorithm only. This is also why the keys need to be stored in a hardware security module like SIM card, because if you steal it, suddenly you can impose yourself as being the other person. So it's very important, and typically telcos deploy it in such a way that there is one key per function, per user on a SIM card. So if you have multiple SIM cards, or if you have multiple SIM cards, for instance, for each of the SIM cards you have your own unique keys, and then you have multiple functions. I will not go into all of the activities, but the most important one, at least, is the KI key, because that is one of those keys that is being used a few times throughout these equations. And this goes on how that exactly works. So in summary, at least the OPC and the KI keys, those are the most important ones. Those guarantee your confidentiality and authenticity of the network. They're created at least on a physical SIM production line, and they need to be shared with the operator. So there are two parties at least that know your card, or at least the keys. Technically, at least, that would be the customer and just the operator and nobody else. At least contractually, and everything else, the creators of the SIM card should wipe or at least securely create the keys on the inside of the SIM card and never see or touch one of those keys. At least that's the idea. It might differ. I mean, in some of the telcos, you have all kinds of guarantees. African telcos don't care that much. They require confidentiality, or the requirement of confidentiality is a lot different. They just want to have data, voice, and being able to contact each other from a very wide area environment, which is a totally different ballgame than what we have here. So how does this change now if you go to a virtualized SIM card? Well, one of the things that would look different from the customer side, here's an example picture, is when you open up your iPad. iPhones and Apple is a bit different ecosystem because now you have iTunes. There are many ways of doing all these key material things and how to start the process, but you have a new app, a new feature on the phone or on the device, an iPad in this case, and then you can select your new possible subscription. Now, what could possibly go wrong here? One of the things that you could think about is that if Apple, in this case, or any other vendor in that sense, is able to tune the list for the most favorable telco of the region where eSIM might be published. And suddenly, how does it's not said yet in how the autoriteit for, so the ACM, there's an authority, at least in the Netherlands, that says how stuff is to be solved, and if they want to allow this kind of functionality, because it's not an actual open system. You could say it's an open list, but if you tune which operator is on the top side of the list, then you suddenly make a change in how people are perceiving the most favorable telco for them. Another cool thing from an eSIM is no more wallets full of SIM cards. An eSIM can load up to 32, at least the bigger chip versions, because some of them will only have room for 6, 8, 12, 16, and 32. The biggest one is the 32. Can have 32 profiles simultaneously. They won't be active simultaneously, so it's not the same thing as having a dual SIM, or in this case, I don't know what the Latin word is for 32, because there's no quadruple 6 trillion profile or dual SIM or quadruple SIM card feature yet in the making. The only one can be active at the same time because the key material needs to be used for the active data and voice networks. But in, for instance, in India and in China, if I'm not mistaken, it is mandatory to have dual SIM phones. Did you know? This is why you see dual SIM phones to be introduced from Asia environments first. It's because it became mandatory to have the ability to have 2 active subscriptions at the same time, and one for data, one for voice, and that you could have a free choice of doing that from one subscription, but you should also have this, the choice or the freedom to do it from 2 subscriptions. So also they like it when they have a possibility for eSIM. It's very practical.
Well, when you say mandatory, do you mean by law?
By law.
And
Consumer law.
Why law? Why does the law require that they have a different plan for data and voice?
Freedom, I don't know. This is one of those things like this is where you have the very wide variety, at least this is how I understood it. They have a wide variety of subscriptions where one would have a very high cost for voice, another one have a very low cost for voice and data cost, and they had all kinds of shenanigans like, I want to have this one combined with this one, and ultimately somebody stated, this is now the law. This is consumer law.
I see, so it's for instance in China, it's law that the manufacturers have 2 SIM slots, but the customers can choose
Whatever they want. Yeah, as long as they have the freedom for at least 2.
Probably also works to freeze out foreign competition if they don't have 2 SIM cards.
Yeah. But eSIM is halted by the Justice Department in the US. It's a very interesting one. The US Department of Justice, the Justice Department, sorry, stated in June 2018 up to at least December 2018, and I don't know the latest status, that the eSIM deployment and development needs to be halted. Interesting. Should be cool, right? New technology, no chips, no fuss with SIM cards. How the hell did that happen? In this case, well, this is how they stated. eSIM standard, which would allow for customers to easily switch wireless providers without having to insert a physical SIM card, la la la. And this is because they could lock you in. In the US, they still have an ability for SIM lock. But if you want to switch your device or make a switch to with it, if you want to switch the SIM card from your device, you should normally be able to pull it out, do an update, and now you're clear enough. But the control now switched from the actual mobile device to the chip, which is branded on the board, which has a different way of being controlled. And because the ability was built in the specifications that you should be that could be SIM locked, the Department of the Justice Department stated, well, hold on, this is too much control for the operator. You cannot even get this phone working if you don't want it in that combination anymore. And this is a new thing because now the control is moved from the SIM card up to a chip that is now on the board of a device that you bought. So you don't have the full freedom of doing whatever you want with that device anymore. And that got different. So this is still to be resolved. Obviously, AT&T and Verizon and so on are very keen of keeping the SIM lock feature. At least that's how they do their business. This is a thing that does not play in the Europe, but it is very interesting to see that it's that important for them. There's also a different way of working with cars, for instance, or I mean, in this case, machine to machine. If you go for a machine-to-machine profile, it's different than for humans. The human profile is stated that the humans should be able to control which subscriptions you are, or which you have, and which one is active. With the cars, if you buy a car, suddenly you don't have, as a consumer of the car, you don't have the freedom of actually selecting the subscription. This is selected by the car manufacturer typically. So at least the brand color that you can see on the left, which is in this case KPN, that one is supplying to Tesla. They are supplying to the SIM cards, which is a module inside of the car. And this is for many of the other devices and other telcos as well. The problem is if this one is moving too much over the border, suddenly you have roaming fees. And in this part of Europe, it doesn't apply that much anymore. But if you go to Poland and you buy a Tesla in Poland or one of the other devices, and then you go to Belarus, suddenly the roaming fees are skyrocketing high. Really high. You can really better much drive very fast to Russia because that's a lot cheaper. Not really if you want to do that, but okay. I hope you have ways of actually recharging your car. Yeah. So how is this being controlled? It's actually controlled by systems like these. This is Jasper, which is a system, or in this case a service from Cisco. So Cisco has many customers. This is just an explanation of a bunch of them, or a bunch of those icons. Some of them are, you see Beeline on the right. That represents not just one telco, but a huge load of telcos in the all the way from the eastern side of Russia to the western side in Turkmenistan and everything else in between. So don't let just say this is just one logo. Some of the logos represent multiple telcos. And emphasize this: the party that is in control of the SIM cards, for instance, the car manufacturer, they log into this portal, see that your cars are roaming a lot, and they pick up the first bill for your car and your data subscription, so they want to move you to another subscriber, or at least your subscription should be moved to another telco, another operator. This is what they do. So the car manufacturer is stating if you are roaming or not, and then move you to another subscription, give you new keys and actually new subscription. It's because they pick up the bill. But if you combine that to risks as exposed to, at least shown from the CCC and Hack in the Box on roaming networks and risks on roaming networks, it becomes very interesting as a new kind of target, because you can now see which car is driving where and make them change onto a roaming network, making changing their attack surface significantly over the roaming networks, because a lot of the roaming networks is how you connect to your telco back home. For example, if you go to, at least with a Dutch, pick anyone, but if you pick a Dutch SIM card and you go to Spain or you go to another country, then if you do where'smyip.com, then typically the statement would be your data came from Rotterdam, which is interesting because you're in Spain. So the traveling of your data went over the roaming networks and then all the way back to Rotterdam. Then it got onto the actual internet and then you moved up. So your data is passing through interesting locations who are not so well controlled in security-wise. So how does this work when you start a SIM card? So the life of an eSIM. One of the profiles starts with the unwrapping of your phone. Now that's surprising. You have a gift card and you scan a QR code. In the QR code there's a specific key for this activation, and you will now combine it with a key which is also in a security enclave on a bit of hardware on your phone itself. And this is what you then send out, and it makes a connection to an SMSR service and redirects you to the right service that has your key material and creates a connection with SMTP+. That's funny, in the past it was all kinds of funky telco networks, network protocols. This is now residing on HTTPS. Suddenly all the telco stuff are moving into the world that I was already grown up in, which is using HTTPS. And even in some of the new specifications for the 5G connections, they are going really interesting into HTTP2 and HTTP3. For those who are known for those kinds of protocols, so keep up with the IT protocols. Suddenly it becomes very important and relevant for all the telco stuff that you're used to, and which we never fully understood. Okay, so if you go to the EUICC, so the SIM card, will now connect to the SMTP+. Also very interesting, it's not your phone. Your phone is in this case just a body, a husk, I don't know, a part. It's a symbiosis in this case between two systems. So the connectivity of the phone is now being used by the SIM card, and the SIM card is now controlling your data from the all the way from the SIM card over the radio networks. Presents the codes for your subscription, and the keys are now being fed back to the SIM card. So the private keys, so these are the KI and the OPC and the other keys. And now you can make your first actual contact to the mobile network. And now it is a normal SIM card with all the applications that we're used to. But it's interesting how this works and started from HTTPS. Yeah.
So it's not really a key exchange, more so that the server in SMTP Plus sends all the private keys to the private key.
Yeah, which is interesting. Sorry?
It's not really a key exchange, but it's just a private key that's sent to...
Yeah, it's not a key exchange, it's a private key that is being sent as payload over the HTTPS connection. Correct. So it's an exchange, so you present yourself, the system can now combine you to the right operator, because that is data that is in the QR code, because the QR code has a badge of the operator that you've chosen because of the subscription. It's not giving you the key directly, so it needs to authenticate. Okay, who are you? You're this phone, and this phone will now get the keys loaded as a payload over the HTTPS connection, which is interesting because you should be able to intercept this or at least work with this. There are ways of doing research on HTTPS connections. The downside of this research is that you have to mimic and replay all the activities that are being done from the UICC chips, and there are some parts which are again hardware enclave, so you cannot really scratch the surface. So that's going to be complicated research if you really want to dive in and do man-in-the-middle attacks here. So just to emphasize on what is the big change on this model, there is a purple line between the where it says physical SIMs. Beamer doesn't really show that purple line that great, but on the left side there's a purple line from the SIM supplier to the operator, and the key materials from the SIM supplier. So this would be from the factory being fed into the operator, and the physical SIM is then deployed to the actual user. This now completely changes into the key material is created at the SIM supplier, but now moved to the purple body, the SMDP+. There is a hardware security module environment again, but it's interesting that this might be a different party. This could be Morpho, this could be Gemalto, this could be Gieske de Vriend, G&D. But it could also be another party. This BlackBerry, for example, states, well, we want to have a very enclosed environment. We're going to run all these services ourselves. That's our kind of business, line of business that we do. So what happens is that the key material is being pushed into the SMTP Plus environment. The keys are copied to the operator. No. And the keys are then being provisioned to the EUICC directly from the SMTP+. So that's not from the operator that you are from typically. And why do they do this? If you want to have this kind of infrastructure, it makes sense to have all the keys into one location or pushed to one location, because then you have only one party to have a contract with. The SIM supplier might have a motivation to be the same party as the SMTP+. And suddenly they're not just creating key material, they now are a part of your infrastructure, which is a different role, because now they have more control of how you work, more control on how you work. That means that they have a different kind of business, not just selling SIM cards anymore, physical plastic devices, but they're now running a service which could scale up and be cheaper. And they might actually state you have that amount of money per interaction or provisioning. And if we scale that up to the emphasizing thought of, okay, we're now moving up to an infrastructure where not 1 or 2 billion devices are the phones that are connected here, but if you include watches, cars, microwaves, printers, whatever, then suddenly it becomes very complicated, and you'll see that there are more interactions on the SMB+, and it's very interesting for them to be in control of those devices. Yeah, thanks for the hint. So yeah, this is again what's different. Okay, you still have the secret keys. They're now being pushed over the network. They're now in control of different companies, not just the operator itself. And there's a different way of bootstrapping them. But okay, what kind of CA would you use? Because the biggest problem of these phones is, well, what kind of certificate authorities would you use? So currently, if you have a browser and you look at the browsers, you have roughly 100 root CAs installed, and this is how you bootstrap the third-party trust system to trust your HTTPS connection. There's a certificate from the server that is part of a certificate chain. It ultimately came from a root CA, and this is how you do this. But which one do you put into your phone? In this case, they started out with none. Okay, but that doesn't work. PKI always requires at least a root CA. So which one do you take? Okay, so in this case, the GSMA, the overarching standards body, stated we're going to do yet another operational thing, and we're going to put in our root CA into this. Unfortunately, in the beginning, they started out with one root CA, no sub-CAs, which means that if there's one key, in this case the root CA key, and only this key is the one key that rules everything for 50 billion devices. So if one or two HSM devices would break, suddenly that entire ecosystem of eSIMs would require you to swap out boards from cars, refrigerators, whatever, to bootstrap or make any changes to the ecosystem itself on 50 billion devices. Now, this is yet another challenge of the IoT environments that we see. It's not so much that you can actually create these kinds of devices. Look at these cool badges. Those are awesome. Have Wi-Fi chips, I don't know what. But you can create them pretty easily. But doing the maintenance, the updates, whatever, sometimes you need to drive over to actually fix one of those devices. That's something that you cannot do if you go for 50 billion devices in one ecosystem. So then they made, so luckily they've listened and they made some changes into this environment. And well, complicated picture, which ultimately states, well, they at least have multiple regions. This was one of the first proposals. This is one of those things where I would say security is cool, business continuity is actually more complicated. And if you want to do secure business continuity management processes, which are also privacy aware, that's the money shot basically that you should aim for. And then it became very complicated. Which CA do you choose? The GSMA had a few people who had American roots, so they chose Symantec. The Chinese said, that's funny, but no go. Think about it. There's a phone of which they would say, no, there's only space for one root CA key, and you have to choose. Would it be an American root CA, a Chinese root CA, and the Russians didn't really bother to mendel in because they found it, I don't know, they didn't have that much interest. But it became very apparent that at least the European countries stated, no, we really want to have a CA that is allied at least to the Americans, so we want to have a Symantec root CA if possible. But the Chinese stated, look, we are so huge with just one operator. We had, for instance, last year, the poverty line changed, at least, I'm stating this differently. Roughly 100 million or 200 million Chinese people raised above the poverty line and suddenly could afford a smartphone. Here today, I can't really realize this because I had smartphones way before there was an iPhone from Sony Ericsson. But now they actually had new subscriptions to the infrastructure, and between October and November, they had 15 million new subscriptions added to the network. Think about the amount of keys, amount of SIM cards, amount of activities that you had to do, when in 1 month, suddenly you have the complete population of the Netherlands swapped out to a new subscription. That's pretty heavy. So the Chinese said, no, I'm going to use my cryptography standards, I'm going to use my key material standards, and I'm going to do this. So the specifications of eSIM now had to incorporate at least those kinds of activities to open up the specification and also deal with this. And now they had to do a different cool thing. And this is where the system, so there is an RFC for such a thing, where the client states, this is the root CA I can deal with. Please swap me around on your reverse proxy infrastructure that you would present me the right certificate because I asked for just this root of trust because this is the root of trust I have. It's an interesting compromise. There was a second motivation of doing this with DNSSEC, which I don't go into due to time. But the thing of that proposal was too complicated to think about because the people who are doing these kinds of standards already made the first mistakes on one single leveled root CA infrastructure, not just double, and think about business continuity management. So they made different problems. So DNSSEC was a technology that I didn't really understand on how that actually worked out in their favor for trust. We had a cool proposal with TLSA and having smart switches in the DNS environment, but this was too complicated. So they resorted to the RFC 6066, which is basically stating, I have this root CA in my system, so please move into, please choose this. So what if the eSIM becomes dysfunctional, if the cryptography would break, if they would break in, do a DigiNotar, and if a DigiNotar effect would happen, or you would steal the keys, suddenly you are in control on how key material is being provisioned up to a huge population around the planet. That's pretty interesting. If this would happen, typically the safeguards would be, okay, let's swap out and disregard this key material. In most of the devices, it would mean throw away. Unless there's a reinitialization support feature to have parties like Gemalto, G&D have an interface back into your phone to swap out key material, change it, while you are in the field, which is interesting. So there is, yeah, did you see me talk about a backdoor now, just this last minute? Okay, good, then at least you got it. The specifications are still in the works, luckily. So one of the things that we at least try to do from where I actually work is to figure out how to improve this system, and we already had some successes, like the single layered CA structure, that it at least is more resilient for business continuity management, that there would at least be used certificate transparency. We are used to that in the IT world. This is what we want to have on our telco networks as well. The GSMA now actually has a cert. Wait a minute, they didn't have this? Well, no, not for this service, but now they do, so that's cool, they're building up. Obligatory Intel sharing, if there is a problem that they would dare to share. This is also something that was still mindset, don't share, because then we don't have that much risks. Disaster recovery plans, and think about crypto agility. So, back to okay, well, what's the last thing that I want to tell you? At least we are moving from the environments of the normal SIM cards up to this kinds of new modelized EU-ICC SIM cards. But even that is miniaturizing after a year or 5 to the system on chip to integrate it. And this is probably how we are going to do IoT in the future. Thank you.
And this is probably the most content-filled talk on this topic I have ever seen, ever. Thank you very much.
Thank you.
Anybody?
Yeah, here. So Oscar, there are still a lot of improvements to be made to the whole infrastructure. Where are these phones, the embedded SIMs, in use yet? So that you can already buy the phones? Oh. Fang. Yeah.
On? Yeah, okay. That'll fine. That'll be fine. If you can go to a modern, you should go to a modern country, like the UEA, or yeah, I'm not even joking. They already have subscriptions where they combine your normal phone subscription with a subscription for mobile devices like wearables. So if you are outside of the Bluetooth range, that you could still actually make the call happen onto your phone. And this is a add-on to the mobile subscriptions because you're provisioned back into your main subscription. So some countries actually have this stuff already. There are countries where you have the Apple phone, the Apple Watch, the iWatch 4. This is, I think, why we don't have this kind of devices here in the Netherlands, because Apple states you have to supply it over eSIM or we don't even sell it. So, and there are countries where you can sell where you have the iWatch. It's called iWatch. I don't have all the Apple stuff. What the hell are they doing? Flamethrowers. Sure. I've never had a conference where they would say, okay, I'm being disturbed by flamethrowers. Any other questions? Otherwise, you can head me up somewhere. I'm here for dinner and the entire night. Bye now.